In the previous lesson, you have learned to evaluate limits using the limit theorems. And you know that such method requires less effort. So limits of polynomials and rational functions, including indeterminate form 0 over 0, can be easily evaluated using our limit theorems. Now let's consider this function. Q of x is the piecewise function 2x minus 1 whenever x is less than 0 and x plus 1 whenever x is greater than or equal to 0. Kung kukunin natin yung limit of q of x as x approaches 0, so dito yon, the value of its limit would depend on which values of x would it take to approach 0. So kung from the left siya, ang limit niya is negative 1, pero kapag from the right siya, ang limit niya is 1. So how will you find the limit of such function? So in this lesson, we will learn about one-sided limits that would help us evaluate the limit of such functions. So yung mga napag-aralan nating limits doon sa nakaraang lesson, they are called two-sided limits kasi wala silang direction, like kung saan siya galing, kung sa left o sa right yung ina-approach. Now, take for example the graph of f of x is equal to the square root of x plus 1. Now, kung kukunin naman natin yung limit of f of x as x approaches negative 1, you can see na hindi natin madidescribe yung behavior ng graph when x is less than 1. Or yung mga values from the left of negative 1 kasi wala tayong graph dito. We can only describe yung behavior ng f of x by taking the values of x na greater than negative 1 or yung mga from the right of negative 1. So now, let's define one-sided limit. The limit of f of x as x approaches a from the left is L if the values of f of x get close enough to L through the values of x which are less than a. And on the other hand, the limit of f of x as x approaches a from the right is L if the values of f of x get close enough to L through the values of x which are greater than a. So, para lang siyang yung definition din natin ng limit. Pero this time, meron tayong from the left and from the right. So, ganito yung kanyang notation. Okay, given the graph, let's find the limit as x approaches 0 from the left of f of x and from the right of f of x. So, dito clear naman, from the left of 0, the limit is negative 3. And from the right naman, the limit is negative 2. So given the graph of g of x, let's find the limit as x approaches negative 2 from the right of g of x and as x approaches negative 2 from the left of g of x. So from the right, nag-approach siya into 0. Karon din from the left, ang ina-approach din niya is 0. So this time, hindi na given yung graph but the equation. So let's consider q of x to be the piecewise function 2x minus 1 whenever x is less than 0 and x plus 1 whenever x is greater than or equal to 0. Let's find the limit as x approaches 0 from the left of q of x and the limit as x approaches 0 from the right of q of x. So in this case, meron tayong function value for x less than 0 and x greater than or equal to 0. So if we are taking the limit as x approaches 0 from the left, we will consider yung mga x's na less than 0 or to the left of 0. And that is etong part na yon. Therefore, for our solution, the limit as x approaches 0 from the left of q of x, yung q of x natin is yung 2x minus 1 ang gagamitin. So we have the limit as x approaches 0 from the left of 2x minus 1. So by direct substitution, evaluate lang natin into 0. So we have 2 times 0 minus 1. So that is negative 1. For letter B, since we are looking for the limit as x approaches 0 from the right means x is greater than 0. So ito naman yon. The limit as x approaches 0 from the right of q of x is equal to the limit as x approaches 0 from the right of x plus 1. So yun ang gagamitin natin by direct substitution, that is 0 plus 1 or equal to 1. Consider h of x to be the piecewise function x squared minus 3 whenever x is less than 2, and negative 2 times x minus 2 squared plus 1 whenever x is greater than 2. Let's find the limit as x approaches 2 from the right and the limit as x approaches 2 from the left. So since meron na naman tayong dalawang values, ito yung less than, ito yung greater than. So sa una, since 2 from the right, yung greater than ang gagamitin natin. So we have the limit as x approaches 2 from the right is equal to the limit as x approaches 2 from the right of negative 2x minus 2 squared plus 1. So by direct substitution, that is just equal to 1. For letter B, since we are looking for x approaches 2 from the left, so eto naman yon, then we have the limit as x approaches 2 from the left of h of x is equal to the limit as x approaches 2 from the left of x squared minus 3. So by direct substitution, that is just equal to 1. Now, balikan natin yung ating example number 2. Observe that the limit as x approaches 2 from the left and from the right are both equal to 0. And also in our example number 4, the limit as x approaches 2 from the left and from the right are both equal to 1. So what does that mean? This leads us to our theorem number 1, which states that the limit of f of x as x approaches a is L if and only if its limit from the left and from the right are equal. So yung left-hand limit equals right-hand limit equals two-sided limit, which is equal to L. So let's consider f of x equals the piecewise function 3x plus 2 whenever x is greater than or equal to negative 1 and negative 2x plus 7 over 5 whenever x is less than negative 1. So let's find the limit as x approaches negative 1 of f of x. So since alam natin na yung limit describes the behavior of the graph from the left and from the right values of a, then dito, makikita natin na yung values of x na nasa left at nasa right ng negative 1, nahati siya into two function values. So yung mga greater than negative 1, ito yung function value nila. Yung mga less than negative 1, ito yung function value nila. So ang tanong, bakit hindi na lang gamitin yung equal sign? Kasi negative 1 naman yung tinatanong doon. Yung limit, describe lang niya yung behavior ng graph before and after yung A natin, but not exactly at A. So since nahati ito into 2, kailangan nating i-check yung limit from left and from the right ng f of x natin as x approaches negative 1. So for our solution, una, the limit as x approaches negative 1 from the left. So since from the left yan, less than ang gagamitin. So ito, we have the limit as x approaches negative 1 from the left of negative 2x plus 7 over 5. By direct substitution, that is just equal to negative 1. Pangalawa naman, the limit as x approaches negative 1 from the right of f of x equals, okay, since from the right, yung greater than negative 1 naman, so we have this. So that is the limit as x approaches negative 1 from the right of 3x plus 2. By direct substitution, that is just equal to negative 1. And since the right-hand limit and the left-hand limit are both equal to negative 1, therefore the limit as x approaches negative 1 of f of x is equal to negative 1. So this is now the graph of our function at makikita nyo na indeed sa negative 1 nga talaga yung limit. So let's consider f of x to be x cubed minus 2x squared plus 4x minus 1 whenever x is greater than 1, 1 whenever x is equal to 1, and negative 2 times x minus 1 squared whenever x is less than 1. So let's find the limit as x approaches 1 of f of x. Again, in this case, nahati yung values na less than 1 at greater than 1. So, to find the limit as x approaches 1 of f of x, kunin muna natin yung limit as x approaches 1 from the left. So since from the left, itong gagamitin natin. So we have the limit as x approaches 1 from the left of negative 2 times x minus 1 squared, or that is just equal to 0 by direct substitution. Sa kabila naman, the limit as x approaches 1 from the right is equal to the limit as x approaches 1 from the right of, eto naman, x cubed minus 2x squared plus 4x minus 1, or by direct substitution, that is just equal to 2. And since the two one-sided limits are not equal, then we say that the limit as x approaches 1 of f of x does not exist. So, ito naman yung kanyang graph. Now, let's consider f of x equals 2x raised to 4 minus 3x cubed whenever x is greater than 0, and 3x raised to 4 plus x cubed minus 2x squared whenever x is less than or equal to 0. Let's find the limit as x approaches 0 of f of x. So, for our solution, since nahati na naman yung values ng x natin sa greater than tsaka less than 0, kunin muna natin yung limit as x approaches 0 from the left. So, that is, ito, the limit as x approaches 0 from the left of 3x raised to 4 plus x cubed minus 2x squared. By direct substitution, that is just equal to 0. Sa kabilang side naman, the limit as x approaches 0 from the right of f of x is equal to, ito naman, the limit of 2x raised to 4 minus 3x cubed. By direct substitution, that is also equal to 0. Since the two one-sided limits are equal, then the limit as x approaches 0 of f of x is equal to 0. So, ito naman yung itsura ng ating graph. One-sided limit is also used in evaluating the limit of absolute value functions. So, for example, we want to evaluate the limit as x approaches 4 of the absolute value of x minus 4. So, for our solution, yung definition natin ng absolute value is equal to the piecewise function x whenever x is greater than or equal to 0 and negative x whenever x is less than 0. With that definition, then we define the absolute value of x minus 4 to be x minus 4 whenever x is greater than or equal to 4, and the negative of x minus 4 whenever x is less than 4. So, since hinahanap natin yung limit as x approaches 4 at nahati yung 4 natin dito, then we take the one-sided limits. So, we take the limit as x approaches 4 from the left, and from the left is etong part na to. So, we have the limit as x approaches 4 from the left of negative of x minus 4 equals, okay, by direct substitution, that is just equal to 0. And the limit as x approaches 4 from the right, eto naman, is equal to the limit as x approaches 4 from the right of x minus 4 by direct substitution, that is just equal again to 0. And both are equal to 0, kaya yung limit as x approaches 4 of the absolute value of x minus 4 is equal to 0. At ito yung itsura ng kanyang graph. Let's evaluate the limit as x approaches negative 3 of x plus 3 all over the absolute value of x plus 3. So for our solution, again, we define the absolute value of x plus 3 to be x plus 3 whenever x is greater than or equal to negative 3, and negative of x plus 3 whenever x is less than negative 3. So since nahati na naman yung negative 3 natin, then we have the limit as x approaches negative 3 from the left is equal to x plus 3. Hindi naman mag-change yung numerator niya, pero yung denominator, kasi absolute value yun, so kukunin natin itong part na to. So, pwede natin i-cancel out yan, which leaves us with the limit as x approaches negative 3 from the left of negative 1. Then, the limit of a constant is just the constant itself, so that is negative 1. Sa kabilang side naman, the limit as x approaches negative 3 from the right is equal to x plus 3 over, okay, so from the right, so eto greater than negative 3, so x plus 3 din. We can cancel that out para maging 1 na lang yan. So that is the limit of 1 or equal to 1. So since the two one-sided limits are not equal, then the limit as x approaches negative 3 of x plus 3 over absolute value of x plus 3 does not exist. Ito naman yung itsura ng kanyang graph. Another application of one-sided limits is evaluating the limit of the greatest integer function natin. Now, let's evaluate the limit as x approaches 3 of the greatest integer of x minus 3. Okay, note that, di ba yung definition natin ng greatest integer function? So, the greatest integer of x implies that x is greater than or equal to n, but less than n plus 1, where n is an integer. So, for example, hinahanap natin yung greatest integer value of 2.4. Ano ba yung less than kay 2.4 na integer? So, 2.4 is greater than or equal to 2, but less than 3. And the greatest integer there is 2. Using that definition, then we know that x minus 3 is greater than or equal to n, but less than n plus 1. Ngayon, kapag itong negative 3 dito, transpose natin to both sides, then we have x is greater than or equal to n plus 3, but less than n plus 4. Using this inequality now, we will write the piecewise function defining the greatest integer x minus 3. So that is so marami yan. Negative 1 whenever x is greater than or equal to 2 but less than 3. 0 whenever x is greater than or equal to 3 but less than 4. And 1 whenever x is greater than or equal to 4 but less than 5. At marami pang kasunod yan. So paano ito ginawa? Ilagay mo lang yung negative 1 doon. So negative 1 plus 3, that is 2. Negative 1 plus 4, that is 3. Kaya nakuha yan. Yung 0 naman, ilagay mo lang sa n. So we have 3 at saka 4. So ganun lang. So since alam na natin yung piecewise function natin na dinedefine yung ating greatest integer function, then, okay, tignan nyo dito, yung 3 na limit, nahati siya into 2. Yung part na to, at itong part na to. Ito yung mga values na less than 3, ito yung mga values na greater than 3. And because nahati siya, kailangan natin gamitan ng one-sided limit. So, we evaluate the limit as x approaches 3 from the left of the greatest integer of x minus 3. So, that is, habang nasa left, ito yon, negative 1. So, that is equal to negative 1. On the other hand, yung limit naman as x approaches 3 from the right of our greatest integer x minus 3, okay, ito naman yung greater than 3. So that is the limit of 0, or that is just 0. And since the two limits are not equal, then the limit as x approaches 3 of the greatest integer of x minus 3 does not exist. Now let's consider f of x to be equal to the greatest integer 3x plus 2 and evaluate the limit of that function whenever x approaches negative 1/3 from the right, negative 2/3 from the left, and negative 1/4. So since yung greatest integer natin is 3x plus 2, then by definition, that is greater than or equal to n but less than n plus 1. Then, i-transpose natin yung negative 2. I-transpose natin yung 2 sa both sides. Then we have 3x is greater than or equal to n minus 2 but less than n minus 1. Dividing all sides by 3, then we have x is greater than or equal to n minus 2 over 3, but less than n minus 1 over 3. So we can now set up our piecewise function defining our greatest integer 3x plus 2. So we have negative 1 whenever x is greater than or equal to negative 1 but less than negative 2/3. 0 whenever x is greater than or equal to negative 2/3 but less than negative 1/3. 1 whenever x is greater than or equal to negative 1/3 but less than 0, and so on and so forth. So since alam na natin yan, then let's answer the first, the limit as x approaches negative 1/3 from the right. So from the right is ito, kasi greater than, yan, greater than negative 1/3 siya. So the limit now is 1 as x approaches negative 1/3 from the right, so that is just equal to 1. Yung second part naman natin, we are evaluating the limit as x approaches negative 2/3 from the left. So negative 2/3 from the left is eto naman siya. So we have the limit as x approaches negative 2/3 from the left is actually the limit of negative 1, which is equal to negative 1. And finally, the limit as x approaches negative 1/4 of f of x. So makikita nyo dito, hindi naman nahati yung negative 1/4 natin, di ba? Hindi katulad sa negative 2/3, meron siyang less than, may greater than. Sa negative 1/3, may less than, may greater than. Pero yung negative 1/4, saan siya nakapaloob? Observe that yung negative 1/4 natin, nandito siya. 0 to negative 1 yan. Negative 1/2. Yan. Negative 1/3. Ito yung negative 1/4 natin. So, hindi na natin kailangan kunin yung left tsaka right hand limits kasi nga, andito naman siya sa loob ng interval na ito. Therefore, the limit as x approaches negative 1/4 of f of x is equal to the limit of 1, which is equal to 1. Isa pang application ng one-sided limits is evaluating the limit of a radical. So dito, di ba, if n is even, we know that yung limit nung nth root of f of x natin, equal lang yun sa nth root nung limit nung f of x natin. Basta yung limit f of x natin is greater than 0. Kasi kapag even to, dapat positive to. Pero kapag even to, tapos negative itong nasa loob, ito yon, does not exist. Kasi nga hindi pwedeng maging negative yung nasa loob nung radical natin, di ba? So meron tayong greater than 0, meron tayong less than 0. What if equal to 0 siya? Ano yung magiging limit ng function natin? Illustrate natin yan using this example. So let's consider f of x to be equal to x minus 4. Observe that as x approaches 4 from the right, so ito yon, from the right, anong nangyayari kay f of x? Ina-approach niya yung 0 from the values of x na positive. Okay? Sa positive siya dadaan. Kapag naman x approaches 4 from the left, yung f of x naman natin, ina-approach niya yung 0 through the values na negative. Diba? Through the values na negative. Yan o, yung mga negative na yan. Dadaan yung f of x natin dyan. Okay? So, etong dalawang to, very important para i-evaluate natin yung event root ng isang radical na equal to 0 yung nasa loob. So, this means, ina-approach niya yung 0 through the positive values at eto naman, ina-approach niya yung 0 through the negative values. That leads us to our theorems number 2 and 3, saying that let n be an even positive integer. If x approaches a and f of x approaches 0 positive, then the limit as x approaches a of the nth root of f of x is just equal to 0. However, if n is even and x approaches a and f of x approaches 0 negative, then the limit as x approaches a of the nth root of f of x does not exist. So parang ganun lang din kanina, no? Ito kasi dadaan siya sa positive, kaya magsi-0. Pero ito dadaan kasi sa negative, so parang magiging negative din siya. So does not exist. So let's evaluate the limit as x approaches 1 of the square root of 3x squared minus 5x plus 2. So for our solution, note that by direct substitution, ano ba mangyayari dyan? That is just a square root of 3 times 1 is 3, minus 5 times 1 is 5, plus 2. Or that is now square root of 0. Since 0 yung nasa loob, pwede natin gamitin ngayon yung theorems 2 and 3 natin. So first, kunin muna natin yung limit as x approaches 1 from the left. So that is, okay, una muna, i-factor natin yung radicand natin. So that is 3x minus 2 and x minus 1. Now, by direct substitution, that is just equal to the square root of 3 times 1 minus 2 is 1. And then, x minus 1 is 0 negative. Bakit 0 negative? Ginagamit natin yung values ng x na nasa left ng 1. Actually, para madali lang siya, ang gawin mo lang, maglagay ka ng value dito na less than 1. Ano ba yun? Let's say 0. So, 0 minus 1 is negative 1. Since negative yung lumabas, kaya 0 negative siya. So, parang ganun lang. Okay? And then, positive times negative, okay, that is now 0 negative. So, parang nagmumultiply ka lang din ng normal na numbers. So, since square root of 0 negative yan, then, yung limit natin does not exist. Sa kabila naman, x approaches 1 from the right. So, ganun ulit, i-factor natin. By direct substitution, that is just equal to 1. And then, ito naman, maglagay tayo ng number, let's say 2. Nasa right siya ng 1. 2 minus 1 is 1. 1 is positive, kaya siya 0 positive. Positive times positive, that is equal to positive. So, that is square root of 0 positive. And from theorem number 2, that is just equal to 0. Pero two-sided limits yung hinahanap. And since the left and the right are not equal, then the limit as x approaches 1 of the square root of 3x squared minus 5x plus 2 does not exist. Now, let's consider f of x to be equal to x squared minus x minus 6 whenever x is less than 3, and the fourth root of x minus 3 whenever x is greater than or equal to 3. So, let's find the limit as x approaches 3 of f of x. So, for our solution, yung limit natin from the left, ito yon, normal limit lang yan kasi nga polynomial naman yan. So, by direct substitution, that is just equal to 0. On the other hand, the limit as x approaches 3 from the right, so ito naman yun. So, we have fourth root of x minus 3. Then, we have fourth root of 0 positive. Kasi from the right of 3, so let's say 4. 4 minus 3 is 1, so positive siya. Then, by theorem number 2, that is just equal to 0. Therefore, the limit as x approaches 3 of f of x is equal to 0.